It not used computer vision methods, for example, cameras, and researches that not involve land vehicles, because many researchers studied boats or even drone images, and also the out-of-scope studies that not addressed traffic object detection in vehicles. So about the filtering process we did, we got an initial set of 516 articles, doing the searches on the databases and using the keywords. And then we filtered these articles. The first step was a title review, so we read the 516 titles and removed 261. After that, there was an abstract review step, removing 102 articles, and then the introduction and conclusion review, removing 98. And finally, the full text review, where we read the 55 remaining articles and removed 36, remaining then 90 studies for the final inclusion on the literature review. So talking about the results, this figure shows a task addressed by the authors, which is the unknown obstacle detection. So the goal of this uh, method is to detect obstacles on the track that are not present in the training set of classification networks. For example, the YOLO network that uses supervised methods. So if we don't have the examples on the training set, we cannot classify this object. We cannot detect this object, this obstacle on the road. So it's a problem for the autonomous vehicle. So this kind of problem is addressed by the authors. And then the general traffic object detection, for example, in the letter A, the instance segmentation for vehicle detection. In the letter B, the lane segmentation and closest object detection. And also the figure letter C, we can see the width estimation and segmentation of unmarked roads, and also the wall width estimation. So on the discussion, this table shows a comparison between the works, and it maps the specific kinds of detection, the main approach, the complementary methods of each paper. On the detection, we can see the tasks addressed by the authors, for example, the unknown obstacle detection, traffic signs and road safety components, safe navigation zone, pedestrians, vehicles. On the main approach, there are some approaches, for example, the semantic segmentation, digital image processing, bounding boxes, also monocular depth estimation. On the complementary methods, that are methods that complement the detection, that interpret the data retrieved from the main approach and are used to complement the detection. Some of them are the anomaly maps, the 2D and 3D image reconstruction, geometric analysis, multitask models, depth estimation using bounding boxes, between others. And this is the part 2 of the table, where it shows the kind of actuation, for example, the speed or braking control, and also the limitations identified by the articles, such as occlusions, the computational expensivity, image quality, adverse and low visibility conditions, and also shows the kind of sensors used. You can see that the RGB camera were used in almost all papers, but one that uses infrared camera, and also the presence of other sensors to complement the RGB data, for example, the ultrasonic, radar, or even LiDAR sensor. About the tasks, so a discussion about them. Most studies identify navigable zones, pedestrians, and vehicles, which are essential elements for the vehicle because we can avoid collisions and um, well, and some works also target the unknown obstacle detection, traffic signs, and road safety components that are also important for the collision avoidance and decision making of the vehicle and the safe navigation of this vehicle. And about the sensors, almost all papers use RGB cameras because they have rich visual data. And a few studies improved the RGB perception with other sensors, for example, the radar, LiDAR, or infrared sensors. And on the computer vision approaches, semantic segmentation stood out for the navigation zone detection because this is a more robust technique to detect the navigation zones because the roads can be a straight line, can be curvy, or can be even occluded by other obstacles or objects. And this kind of object could not be represented using bounding boxes, for example. And the bounding boxes technique stood out for common object detection, for example, vehicles, pedestrians, and depth estimation technique were used to improve the 3D perception to give this sense of depth and distance from the objects. And several papers also combined tasks like object detection and lane detection in one single model using multitask approaches, so it's also interesting. About the complementary techniques, anomaly maps were used to identify the unknown objects, and geometric analysis and bounding box-based depth estimation were used to employ the spatial understanding to really give this sense of distance estimation from the obstacles. And common filters and object tracking were used to improve the temporal perception in the detection. About the system's actuation, only a few works implemented speed or braking control, for example, and most of the studies are focused on purely perception in implement the system to detect the objects. And about the main limitations identified, one of them was the high computational cost, especially in semantic segmentation, monocular depth, and multitask models that are heavy approaches to run, and also the adverse weather condition and low visibility conditions. And the lack of lane markers and unusual objects were also identified as limitations. About the datasets used by the authors, these both images shows some examples of datasets of general traffic object segmentation. In this case, on the left we can see the new scenes dataset that has annotated masks of road segmentation and object detection and segmentation. And on the right, we can see the cityscapes dataset, which is specific for semantic segmentation of traffic elements. And these both figures shows the non-obstacle detection datasets. On the left, we can see the road obstacle 21, which has two classes, the navigation zone and also the non-obstacle. And on the right, the road anomaly dataset, which shows a dataset that has masks of segmentation for anomalies and non-obstacles. And this table here shows the datasets, all the datasets used by the authors to train or even validate their solution. And many sensors were used, for example, the stereo camera, in some cases, monocular camera. Some datasets employed more sensors like LiDAR, radar, IMU, and GPS units, for example, new scenes and PandaSat. And the tasks, there are also many tasks annotated by these datasets, for example, the non-obstacle segmentation, navigation zone segmentation, 2D and 3D detection, 2D and 3D segmentation, object tracking, and lane detection. Some datasets are specific for some tasks, for example, the CU lanes, TU simple, and curve lanes for lane detection, and also 2D segmentation with COCO and AD20K datasets. And that's very interesting because all of them are open source, so we can download in the website and also study these datasets, see the masks, and this is very interesting. So now about the conclusions and future work. So computer vision and AI techniques have showed great accuracy on detecting traffic objects such as vehicles, pedestrians, and navigation zone, and this is very important to the vehicle safe navigation. And deep learning and vision transformer based methods play an important role in scene understanding. So this kind of methods can identify complex objects, the non-navigation zone and navigation zone, which is also very important to the vehicle. So we can know if an obstacle is inside the navigation zone or is outside, or a vehicle also. So it's important to know if this kind of obstacle would be dangerous to the vehicle navigation or not. And combining perception tasks such as detection and segmentation in one single model in multitask models demonstrated to improve the computational efficiency and computational complexity, low visibility, and extreme weather conditions remain as challenges for those authors. But to address these limitations, the authors also fuse the RGB data with LiDAR, radar, or even infrared sensors, and these approaches has shown positive results to avoid these limitations. And about the future research, we intend to fuse in next articles semantic segmentation and monocular depth estimation to improve the detection of navigation zones, objects, and obstacles. And the main objective is to advance the environmental perception and also the scene understanding techniques to improve the safety of autonomous vehicles and ADAS. And this is our main motivation behind the works. So these references were used to do the slide presentation. And thank you very much for the attention. And I'm now open to questions.
All right. Thank you for good giving us good presentation even in virtual. Thank you, Victor. And
Thank you.
any question? No. All right. I have a question. You uh, you have done many paper reviews, right? Over 500 papers. So is there
Yes.
any issue related with attack in this system? Attack issue?
I'm sorry.
Because,
What?
yeah, is there any attack issue in this field?
Oh, the issue? What do you mean?
Yeah, attack issue. Because I think attacker can spoil this system.
I
Safety.
didn't understand the OT part. Can you like type?
Hmm?
Can you type?
Because if you attack or enemy can spoil this safety system, navigation system. Is there any issue, attacking issue in navigation system? No.
You say on the navigation system proposed by the authors.
Yeah.
Any issue on that?
Yeah. Right. That
Okay.
is my question.
Yes, we have the actually the limitations that are identified by them, and the main
Hmm.
limitations were identified as problems with the RGB cameras, uh, such as the occlusions, low visibility, and diverse weather conditions. And these are the main problems of these kind of systems because they are very they can be very, how can I say, um, this kind of conditions can be worse to the system, can be bad. Uh, and that's why authors also propose using another sensors to complement this kind of data.
All right. Thank you.
Thank you. Thank you
All
very
right.
much.
Yeah. Thank you very much. Okay. Second paper is Professor. Yeah. Phobia. Yeah. In prison.
Yes, I have to share this presentation from the. Sorry.
Okay. All right. Oh, just start?
Fantastic.
Not working?
Yes. Of course it's not working. Yes.
Well, yeah, is it?
Okay. This one.
Okay.
Up and down.
Yes.
Okay, okay. All right. Thank you everyone for joining us this morning. As you're supposed to be in Fabio, here to virtually, let's say this way, presenting my grad student Sophia's work entitled Accessing the Relationship Between DevOps Practices and Customer Satisfaction, a Preliminary Analysis. Well, over the past decade, you know that digitalization reshapes business strategy and operations. So DevOps is one of these approaches or techniques that tends to integrate development and operations to improve delivery speed and quality software. So what are the core principles of DevOps? Automation, metrics, collaboration, continuous improvement, and so on. Okay. What is our critical research gap? Well, on the literature, you can find just the analysis of DevOps metrics. So our research emphasizes technical metrics of DevOps, but customer satisfaction remains underexplored. So what really happens when you apply DevOps development with the customer satisfaction? So our objective is to analyze the relationship between DevOps maturity and business customer satisfaction. So our main contributions are integrate satisfaction into DevOps models, propose a methodology, so we are analyzing internal versus external features and presenting initial findings. Well, DevOps and performance metrics we have, for example, in the literature, the DORA metrics, which stands for DevOps Research and Assessment. Between them, we have deployment frequency, lead time for change, for example, mean time to recovery, change failure rate. They are all consolidated metrics in the literatures. And we have found that, of course, companies with advanced DevOps operation, they tend to have fewer failures and fast recovery. So, in addition, we conclude that culture really matters, as we can read on other researches. So a critical indicator of a company's success is customer satisfaction. But how do we measure and evaluate customer satisfaction? We can, for example, use the so-called Net Promoter Scores that are a methodology that tries to make companies categorized into some different levels. And in Brazil, for example, we have a website called Reclame Aqui. It's something like claims right here that has implemented Net Promoter Score. So how can we measure if tech companies implementing DevOps, for example, are with high scores audited by external users, as this web platform is to do? So we have find a lot of related works trying to measure DevOps, or for example, trying to measure just the customer satisfaction. But none of them seems to try to compare and see if one has a correlation with another one. So our research methodology is a mixed approach where we have combined internal DevOps metrics with external customer satisfaction data. We have used the metrics that I have already cited. We have collected, we have a survey with 62 IT professionals across the major 23 Brazilian companies, and we have measured DevOps maturity in cultural dimensions. After that, we have applying Pearson and Spearman correlation for statistical confidence to see if they present or not a correlation, both for quantitative and as well as qualitative. So our survey, we have respondents profile from different roles: software developers, DevOps engineering, system administrations, IT manager, agilists, site reliability engineer, all of them with high experience in DevOps. We have used the DORA metrics as for internal measures. We have analyzed by using the survey design, the organization culture, addressing, for example, Western's model, lean development, and burnout and well-being characteristics from the employees, and so on. Our survey is not full this way, is cutting something right here, but anyway, okay, you can go this way. So our survey structures have a total of 36 different questions across 8 different points of view. So by trying to measure data metrics, organization culture traits, team burnout, so there are specific questions about how do you try to measure, for example, burnout questions. It's a self-respondent questionnaire, of course, and it's a little problem of our code. So we have customer satisfaction. How do we measure? As I have said, reclame aqui, RA metrics, they utilize a Brazilian premier customer feedback platform as our external data source. What they use to calculate this score: the response rate, the average evaluation, all of them are from point of view of customer, okay? Solution rate, return business rate, and applying this formula with such weights, they reaches a score. So here we have some sample data review. We have find 62 responses. This is an average mean time to recover, average lead time, deployment months, whatever. These are just a few numbers, but the most important slide from my point of view is this one, where we can measure correlations between survey variables. This way, here we have DORA metrics and the other questions about a lot of point of views from collected from the researchers. And here we have the Spearman and Pearson correlation, or where we have positive or we have negative correlation. So what we can infer from this slide, we have a moderate negative correlation defined, as you can see right here. So Pearson and Spearman coefficients indicate that lower CFR or change failure rate values, lower change failure rates values are associated with higher customer satisfaction. You know, so this is a statistical test. Deployment mirability matters, or CFR was the only DORA, the only one from the other metrics to exhibit a significant correlation with RA scores. So when you lower CFR, you have higher satisfaction, customer satisfaction scores. Supports theoretical expectations, so this confirms that deployment stability is a critical driver of customer perceived quality. In practical implication, of course, reducing change failure rates may have you greater external impact than faster, more frequent releases. So we have statistically, we know we have to improve the sample, but we have in some way calculated this. And our key finding As you can see right here, with Spearman and data in Pearson, is a moderate negative correlation, as you see, is a moderate, between change failure rate and array scores. Or when you lower CFR, you can see by the point of view of external customers that they try to evaluate better your product and your company. So there is a correlation shift. Interpretation, fewer failures implies in higher satisfaction. Conclusion, deployment reliability is crucial. It's there, it's shown. But we have some unexpected findings as well. Let's see, here we have some neutral correlations applying both of these statistical tests. So deployment frequency, MTTR, and lead time has no significant link with satisfaction. So it seems that it doesn't matter when you change inside your company by using these specific metrics. No one perceives this external. So implication, reliability may matter more than speed. So you have, this is not how frequently you develop your software. You know, so contrast change assessment over the literature. And here we have seen the role of culture, the culture of DevOps. So let's see. Shared responsibility, collaboration, innovation has a positive correlation with satisfaction. So when you lower one, you lower the other one. So it's not the contrast. So culture impact, it seems that is stronger than some DORA metrics. So the culture impact of adopting DevOps seems to be more strong than the metrics you use to measure DevOps inside companies. So we have threats to validity as well, as internal, external, construct, and statistical one. Internal, we'll have a self-reporting bias, so people are responding by themselves. We have external problems. This is uncontrolled factors. We have external, we know, it's a small sample, localized sample. We have distributed almost 500 surveys across the main Brazilian companies, but only 62 have responded. But anyway, construct, we have to improve our customer type, and statistical, we have to improve our sample in order to have more statistical confidence. So in conclusion, we can say that CFR really correlates negatively with array score. Culture matters, collaboration, learning, support, satisfaction. Efficiency is different from satisfaction. Whatever, cultural and technical excellence both needed. We need both of them. We need apply efficiently, but we have measured satisfaction as well. Some recommendations we have to lower CFR, cross-functional teams, shared ownership, learn from failures, and our future works include large samples, or we really need to enhance our statistical power, indirect factors, culture, productivity, team dynamics, longitudinal studies. We need to track DevOps maturity over the time. For example, by using these same 62 companies, we have to measure again to clarify if this correlation keeps over the time. And we have mixed methods, combined surveys with a lot of other types of interviews. I think that's it. Questions?
Okay, thank you for giving us good presentation in presence. Okay. All right. Any questions?
That's it.
Okay.
No questions?
You introduced many metrics related with
DevOps?
customer satisfaction.
This one.
So yeah. And reliability is the same availability.
Reliability is the same that availability. I think one has close dependence of the other because to be available in such a way you have to be reliable. So I think there is a direct correlation. So different metrics for dependent things. I would say that way.
Because my research field is security. So in
Okay.
my field, yeah, availability is more important
Mm,
in the server, even server. So I test ask them.
yeah.
Okay.
And remember, this is a graduate student's work. It's not even a master's degree. Just a graduate. That's it's impressive because she's going to master's degree and plans to refine and improve this area of research. It's interesting.
All right. Would you give her? Thank you. Okay.
Can you hear me?
Sir, the presenter, where is? Okay. Mr. Ning, and are you ready to present your paper?
Yeah. Um,
All right. And okay, let's just start your presentation.
okay. Okay. I will presentation about our paper. Our paper is enhancing money laundering detection, computational study of machine learning techniques and sampling methods. And I'm Nguyễn Hoàng Kha from FPT University in Vietnam. And our content is five part. First one is introduction, related word, report method, experimental result, and last one is conclusion. First, introduction. The challenge of money laundering and AML system background is the drug trafficking, terrorism, and human trafficking. The traditional AML limitation is evolving transaction complexity. Techniques like submerging, breaking large sum into smaller one. So multi-stage laundering, from placement, layering, iteration. So urgency for event method is FAT app, TrustNet for sophisticated detection system. So the traditional model lack adapted to hidden and dynamic launching pattern. So the leveraging machine learn to improve the AML detection. The machine learning advance in AML is machine learning model uncover hidden pattern in complex transaction data. So the key challenge is last imbalance. So the vast majority of transactions are legitimate minority class. Imbalance cause machine learning model to mislead C5 regional activity. So research work we have SMOTE, random understanding, ADA SYN, and TED approach in SIG model, SIG machine learning model, random forest logistic regression, K-neighbor, radian boosting like GBM, XGBoost. So dataset we use AML regression from Kango. So next one is related word. We have the supervised learning methods and last imbalance in fraud detection. Uh, common model like logistic regression, decision tree, random forest, and neural network. In average last imbalance sampling techniques, we have the random undersampling SMOTE and ADA SYN. So our post methods, we have the first we have input data, and then we put data into the data processing. We encoding category, counting data, and split data into chain and test further. So then we give it into the classification model algorithm, random forest, radian boosting IDA bush, SG bush, and then we have sampling method with that without sampling, random undersampler, SMOTE, and near miss, also with IDA S1. And then we compare and evaluation the result, like accuracy, F1 score, GOC, or OG. So the dataset overview, we have the dataset from IBM transaction from anti-money laundering Tango, more than 5 million transaction entry, and the attribute is 11 attribute future. You can see in the table, we have the table from other datasets. We have 11 attributes. So there's report method. We have the data set processing. We handle missing value and code, categorize a variable, inject time-based future, hour, day from time lab, and ensure data quality and consistency. And we use in environment, we use rule of Colab Pro and Python 3.10. And imbalance learning technique, model machine learning model, we address last imbalance from random sampling, reduce maturity last side by remove sampler, MLTE and IDA S1. So in the classification model we use is a random forest, logistic regression, K-neighbor, and gradient boosting, also large GBM and SGBoost. So in the model implementation, we have random forest, logistic regression. We have the loss function of this is a formula, and a K-neighbor. It have a decision metric, and so the formula of this, and the gradient boosting, we have also a loss function, and that is a formula. Large GBM, also SGBoost, we have loss function with regularization. Uh, about the experimental result, we you can see in the table we compare with SIG model we propose, and with sampling method we have 4, and you can see in the random forest is have a high. Also we have the table to comparing F1 score of model and sampling methods. So the conclusion, the key finding random forest are performance on order at one score. We have 0.37 no sampling and 0.41 with smoked and 0.1 with ADA as well. And we robust across all setting. And in the logistic regression, K-neighbor, low F1 score across all sampling territory and limit the effectiveness in the detection. Last one, in the gradient boosting like GBM and SG boost, the moderate improvement with SMOT and IDA as well, but did not match the random forest performance. So the inside collusion, the smoke and SMOT and IDA S1 effect for minority class improvement and random under similar results may degrade majority last performance and collusion with random forest plus SMOT and IDA S1 is the best performance. Last fire got sampling combo is used in the IML detection. So in the future work, we explore expand involuntary and horizontal tutoring and investigate more model for improved first detection. So that's all for my presentation. Thank you for your listening.
Okay, thank you for giving us a good presentation virtually. And any question? No? I have a question. What do
Yeah.
you think about, what do you think, what is the most important contribution in your paper?
We compare in attribution in my paper, right?
Mm-hmm.
We compare with a lot of model to see what is the best methods to apply to the AML detection. Yes, we have compared a lot of model and some method to see is what is the best performance, also the accuracy in our contribution. Yeah.
Okay. How many data did you use for modeling or test?
Yeah, we have one data set. Yeah,
Okay,
we
good.
have the data sets. We use yeah here. Data set we use is yeah is data sets we use one data set and its recording is more than 5 million transaction. Yeah.
Okay, thank you for answering.
Yeah.
And would you give the applause to him? Okay, thank you.
Thank you. Thank you.
Okay. All right, now we have a fourth presentation. Fourth present. Sarah?
The next is online, so
Ah.
he has to share the screen.
Okay.
Yes.
I will show. All right. Good morning, Mr. Fabricio. Would you start to present your paper? Are you ready?
Yes,
Okay,
yes,
let's start.
thank you. Good morning. I'm Fabrício Breve. I'm from the São Paulo State University, Unesp, in Brazil. I present the paper classification of strawberry maturity levels from image using supervised classifiers and convolutional neural networks as feature extractors. The first author, Erica, was my MSc student. So this paper is this paper is derived from her master's dissertation. So the motivation of this work is that strawberry is a perishable and non-climateric fruit, which means it does not ripen, it does not continue to ripen after harvest. Some fruits you can harvest earlier and they will continue to ripen on their way to the market, but it's not the case with the strawberries. And it's cultivated worldwide. It's very popular for its sweetness, taste, nutrients, and they grow. The growth cycle has three main phases, which is flowering, fruiting, and ripening. But there's no single standard for determining the ripening stage of the strawberries. So the farmers have to inspect them manually, and this is inefficient and it's time consuming. So the objectives of this work is the main goal of this work is to develop an automatic system to predict the maturity of the strawberries. And the strategy used here is Eric evaluated these 71 different convolutional neural networks architectures to extract groups of deep features so she can classify the strawberry images. These deep features are fed to a group of 10 different supervised classifiers. And the idea is to find the best combination of convolutional neural network and classifier for this specific test. The data sets used are those two. The first one is smaller and the second one is larger. And in both cases, a specialist get each one of the images and classify them as harvest or not harvest. So for instance, in the first data set, this is a harvest image because we can see that there are two strawberries here that are ready to harvest. And here is a not harvest example because all the strawberries in this image are not yet ready to harvest. This is the other data set, the larger one, and this is the same idea. Here we can see that there are strawberries ready to harvest. Here we can see that there are strawberries, but they are not ready to harvest yet. Here are the 71 evaluated architectures. Uh, some of them belong to the same family. So here they are separated by family. So 71 in total. Weights were pre-trained on the ImageNet dataset, so it's a transfer learning scenario. We use the principal component analysis to reduce the dimensionality of this network. So instead of using thousands of features, we kept only 90 to 95, 99% of the variance from the original features. So there's a total of 7,100 combinations. It's a huge amount of combinations of convolutional neural networks and classifiers. These that are those in blue here were only tested on the smaller data set due to some memory issues, some memory restrictions on the machine. She was running the experiment. So the first data set, all of these networks were used, and the second data set, only the one in black, those one in black. Here are the supervised classifiers used. There are popular classifiers, classic classifiers that are found on the literature. The implementation was done using Python. TensorFlow for the CNN implementation. So all CNN implementations are from TensorFlow. The supervised classifiers are from the scikit-learn toolbox. And Erica used the Google Colab free version, meaning that she had 12 gigabytes of RAM and different hard configurations in each connection. She had to connect many days to run all these experiments. The methodology for each combination of CNN and PCA configuration, 10 different PCA configurations plus classifiers. She used the training with and without weight balancing, except for KNN, NB and GB, because they don't have an option to balance to compensate for the data set imbalance. She performed the k-fold cross-validation with k equals to 5. And the evaluation metrics were accuracy, F1 score, recall, and precision. Here we have some results for the first data set, the smaller one. So from all those thousands of different configurations, these were the 10 best ones. What is interesting here is that 3 different classifiers appear, like gradient boosting, histogram grade-based boosting, random forests, were the best in each of these metrics. So gradient boosting for F1 score, histogram-based gradient boosting for the accuracy and for precision, and regarding recall, random forests get the best results. Also, it's interesting that VGG family here got VGG was among all the networks tested, this is the earliest one. So it is interesting that they got some of the best results here, together with ConvNext, which is the newest one. And also interesting is that some of the best results does not include does not include any compensation for class imbalance. And for the larger data set, there are different results here. In this case, the ConvNext family dominated. Even though the larger models of ConvNext were not applied to this larger data set due to those memory constraints, but still ConvNext got the best results, together with gradient boosting for accuracy and for F1 score, with support vector machines for recall, and the histogram-based gradient boosting for precision. Also interesting to see that in the 10 best results, only up to 95% of the 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 variance was needed to get the best results. So this means that there is probably some redundancy in the CNN output. So in conclusion, CNN have proven effective in classifying Strawberry's maturity levels due to their ability to extract detailed features from the images. The best results were achieved using feature extractors, convnexts, and VGG families, which is interesting because it's the newest and the earliest families. The best classifiers were gradient boosting, histogram-based gradient boosting, and support vector machines. And PCA, the best results were with PCA retaining 90 to 97% of the variance. And that's it. Thank you.
Okay, thank you for giving us good presentation. And I have a question. And what is your future work in this field?
Sorry, I didn't
Future
understand.
work, yeah. What is your future work in this field?
The features
Is there
are those
any?
from the convolutional neural networks, the output from the convolutional neural networks that we tested, those 71 different convolutional neural networks. This here.
Okay. Okay, any question to him? No? Okay, let's finish this presentation. Would you give the thank you, Mr. Fabrico? Okay. Okay, last one. We have remain one paper. Okay. Mr.
Hello?
Okay.
Can you
Are
hear
you
me?
ready to present to your paper?
Can you hear me?
Would you share your presentation paper?
Okay. Can you see it?
Yeah.
So, hello, my name is Evgeny Mutarin. I'm assistant of Information Technology Department, Ulyansk State Technical University, Russia. Today I'm gonna be talking about software system for intelligence and monitoring of storage system through logs analysis. Modern technical systems such as data storage servers are highly complex and generate vast amount of data. Traditional monitoring method struggle with uncertainty, accuracy, and scalability. Our solution combines two powerful approaches: machine learning, which adapt to dynamic conditions, and fuzzy ontologies, which formalize expert knowledge to handle incomplete or noisy data. This hybrid approach enables predictive diagnostic, future lacking in existing tools. Today, I'll walk you through how we achieve this. First, let's discuss existing tools. First is Papertail is a popular short form for collection diagnostic data from text files, database like MySQL, and application like Heroku. While effective for log aggregation, it lacks predictive capabilities. It operates only real-time, unable to forecast future system states.
This limitation motivate our work to develop a more advanced solution. Next is Logly, is another tool for real-time log monitoring across devices and applications. It supports multiple protocols like syslog and HTTP. However, like Papatrail, it focused on real-time analysis without predictive feature. Our research aimed to bridge this gap by editing forecast capabilities to such system. Next is SamaLogic, is a cloud-based platform for log management and security. It offers robust data collection and analysis, but again falls short in predictive diagnostic. Our hybrid model, as you see later, enhances the functionalities by integrating machine learning for future state prediction. And last is Splunk, is a well-known platform for real-time data monitoring and visualization. The speed is strength, it does not predict analytics. This common limitation across all tools underscored the need for our solution, which combines real-time analysis with forecasting. So, to identify the best approach, we evaluated several methods. Cluster analysis is fast but less accurate. Autoencoders often high accuracy but are slower. LSTM network excel in accuracy but lack interpretability. Fuzzy ontologies provide interpretability but moderate accuracy. Our hybrid model outperforms them all, achieving 98% accuracy with maintain high interpretability and noise resilience. This makes it ideal for rework application. Our platform serves two user group, domain experts who create fuzzy ontological models and rules, and system users who analyze data. Users upload CSV file, select metrics, and detect anomalies using LSTM or fuzzy ontologies. The results include semantic interpretation, offering actionable insist, and this dual user design ensures flexibility and expertise integration. The platform comprises three key models. First is pre-processing model for data loading. Second is neural network model using PyTorch for LSTM training. And last, fuzzy ontology models with OVL files, several rules, and the fully ontology plugin. Together, the model enables seamless anomaly detection and interpretation. Users start by uploading CSV file, contain time series data such as error logs. The file must include a data column for metric alignment. These steps ensure the data is ready for analysis and visualization. Next, user select a specific metric from the database, like total number created, and these metrics will be analyzed for anomalies. The interface is intuitive, allowing the user to focus on relevant data point. Clicking a button, plot a graph generates a time series visualization. The x-axis show data, and the y-axis displayed metric values. This helps user with ability to identify trends and potential anomalies before applying advanced analysis. The LSTM anomaly search button trained the neural network. The architecture includes conv-LSTM1D for time dependencies, conv1D transport for reconstruction, and dropout to prevent overfitting. Once trained, the model highlights anomalies at the red dot on the graph. Let's delve deeper into the LSTM architecture. The conv-LSTM1D layer processed sequential data with convolution operation. Conv1D transport reconstructed the input and dropout ensure robustness, and this design balances accuracy and compatibility efficiency. Users can load fuzzy ontologies in OVL RDF format. This format contains classes, properties, and several rules. For example, a rule might state if total num creator exceeded 200 to flag a synchronization failure. This Rails enables semantic anomaly detection. Here metrics. Some such rules automate decision making, combining LSTM outputs with expert knowledge. Clicking fuse anomaly search, processing the ontology. Each metric is evaluated using trapezoidal membership function to assign anomaly probabilities. Several rules then generate conclusion, blending machine learning with fuzzy logic. Users can adjust the upper bound of a trapezoidal function to define when a metric is 100 anomalous. This flexibility allows customization based on system requirement, enhancement the platform adaptability. Conclusion. In summary, our platform integrated LSTM and fuzzy ontologies to detect anomalies with high accuracy in interoperability. It supports data loading, visualization, anomaly detection in semantic analysis. Looking ahead, we plan to adapt the system for real-time data streams and expand its use in industrial settings. This will future available is practically instability. So that is reference we used in this paper, and thank you for your attention.
Okay, thank you for giving us good presentation in virtual. I have a question. Which data did you use in your experiment?
We plan an experiment with another neural work for compare some neural model. This is planned in future. Today is not planned.
Okay. Would you give to him? Thank you. Okay, all
Thank
right.
you, thank you.
Finally, we finish our session. Okay, right. Thank you for attending this session. Okay, finish.
I wanted to ask and also to mark the should I do? ICCSS dot
A interna e a externa. A interna a média dentro. Qual é a percepção que você tem fora? Mas nada no meio. Ou lá fora,
there's the space here. There's no.
That please.
Yes, another one. Sorry. Yes. Then
On the left,
it's
maybe minus.
yes, minus.
And B. And selection.
Yes,
Evaluate session.
yes.
Evaluate.
Evaluate
Session.
sessions with yes, yes.
Session.
Sessions dot
That time.
yes, that's it. I think that you have to log in
Okay.
in your and then evaluate each
Okay.
field.
Thank you.
At the end of the form, there will be 3 buttons. All the presenters were
Okay.
They all presented, so you have to mark
Okay.
the presence. Okay, thank you.
Thank you. I'm looking.
I'll be right back.
Okay.
Sorry. I have to do
Uh-huh.
the last. No, no, I think that's